Hi everybody. Here we have an interesting shape. We have I like to call it a basketball key. Okay, where it's one of those shapes where you kind of have the foul line here, right? The basket would probably be somewhere there, and you have the region within. Okay, and then like the 3-point line would be like over here like this. Okay, but in this problem, it's not the purpose of this problem is not to demonstrate a basketball key. The purpose of this problem is to find the area on the inside of the shape. So what it means is we're going to try to find the total area that exists inside the shape, and it's going to be very similar to what we were doing with other composite shapes. What we're going to do is we're going to take the area of shape 1, which is actually going to be this rectangle right here, and we're going to add it to the area of shape 2, which is going to be that circle. But we're going to be really careful when we add the area of shape 2 because, in fact, we don't want to include this region here when we figure out the area of shape 2, because if we do, we'll be adding it twice because we already figured out this region when we did shape 1. And so that's where you just got to be a little bit careful with these questions to make sure you're actually figuring out the area of what you're supposed to be figuring out. So the area of shape 1 is quite straightforward. The area of shape 1, this entire rectangle from here to here, is just going to equal to length times width. And that will equal to 15 feet, that is, FT is feet, okay, which is what we call an imperial measure as opposed to a metric measure, times the width, which is 10. And 15 times 10 is 150 feet, right? Feet squared. Now the area of shape 2, obviously shape 2 is a circle. To figure out the area of a circle, what we need to do is we need to use our formula, which, if you remember, is pi times radius squared. So we know what pi is. Pi is 3.14, but we also have another problem. The problem is that we don't immediately know the radius. That should be pretty easy to figure out. But also, we have to remember that we're not really figuring out the area of a full circle at the end because we only want to add on the area of this portion of the circle, which is half a circle. So really, what we need to do is we need to take, if we want the area of shape 2, it's a circle divided by 2. It's a half a circle. Okay, that's a thing. We don't want to add on the area of a full circle because the full circle would include this portion, and we've already counted that portion in our calculation for the rectangle. Okay, that's a very important concept. So what is the radius of our circle? Because we can't do anything unless we figure that out. That's actually not as hard as you think. The radius of the circle can be figured out using this line here. We know that that line that I just drew in is 10 feet. Okay? And that 10 feet is the diameter. It's the distance across the circle. Well, the radius is half of the diameter. So the radius will simply be the distance from here to here. So the radius is going to be equal, or will be figured out by going 10 divided by 2, which is 5 feet. Okay? And now we've done the work necessary to figure out the area of shape 2. Area of shape 2 will equal 3.14, which is pi, times the radius squared, which is 5 squared, divided by 2. 3.14, okay, so 5 squared is 25, we must do bed mass, times 3.14 is 78.5, so let's give ourselves some more space. Okay, right there, so area 2 is equal to 78.5 divided by 2. And what does that equal? That equals 39.25. Okay, so area 2 equals 39.25 and it's going to be feet squared. So total area is going to equal 150 plus 39.25. Okay, so 150 plus 39.25 is equal to 189.25 feet squared. Okay, and that will give us the measures that we're looking for in this case. Okay, so that in this case, the total amount of space that exists inside our basketball key, which is all of this plus all of this, is equal to 139.25, or sorry, 189.25 feet squared. Great, I hope you found that helpful.